Welcome back to the physics class. Today we shall discuss about a very important term related with radioactive decay, that is half-life. The time interval in which one half of the radioactive nuclei originally present in the sample disintegrate is called half-life of the radioactive substance. So you see, the term half-life relates exactly with its meaning, that is, the time required to reduce the number to one half of the original. To understand this, look at the figure given below. You have an initial sample at t is equals to 0. There are some number of nuclei present. After one half life, we have half of the total number of nuclei present initially left in the sample. After another half life, the number decreases to half of the previous. Let me take an example and explain this. Let us say at t is equals to 0, our sample has 64 nuclei present and the nuclei has a half-life of say 2 hours. It means initially n naught is equals to 64 at t is equals to 0. Now as time proceeds, after 2 hours, the number of nuclei left in the sample would be half of 64, that is 32. After 2 more hours, that is total 4 hours from the beginning, we will have 16 nuclei left in the sample. After the third half-life, we will have half of 16, that is 8 nuclei left. After the fourth half-life, we will have half of 8, that is 4. Thus, the number of nuclei in the sample goes on decreasing with the increase in time. This is what we mean by half-life. It is the time during which the number of nuclei reduces to half of the nuclei present initially. Let us now see the variation of number of undecayed nuclei with time. This graph is an exponential graph. When we write and understand this, we see that at t is equals to 0, total number of nuclei present in the sample is n naught. After one half life, that is t half, the number falls to n0 by 2. After the second half life, that is 2t half, the number becomes n naught by 4. After third half life, it becomes n naught by 8. After fourth half life, it becomes n naught by 16 and so on. The important point to be noted here is that initially the rate of decay is very fast. That can be seen by the steep fall in the shape of the graph. As time increases, it takes long duration for the radioactive nuclei to reduce to 0. Ideally, this graph goes almost parallel to the x-axis and meets x-axis at infinity. So we have the exponential graph for the decay of nuclei with respect to the time. Let us now derive an expression for this half-life.
We start with the formula for the number of nuclei that remains undecayed in the radioactive sample. It is given by n is equals to n naught e raised to power minus lambda t. Now we are talking about half-life. So at t is equals to t half, that is when one half-life happens, n becomes n naught by 2. The number of nuclei becomes half of the original number present. Let us substitute this in the formula. So we have n naught by 2 is equals to n naught e raised to the power minus lambda t half. Here we see that n naught gets cancelled and we are left with half is equals to e raised to power minus lambda t half. I'll take reciprocal on both sides, so it becomes 2, and on the right hand side the power turns into positive. Now because we are deriving for t half, we need to remove the exponential. In order to remove the exponential, we take log on both sides. So this is log of 2 is equals to lambda t raised to the power half. This is the natural logarithm. This gives us t half is equals to log 2 upon lambda. This is a natural log. When we have to convert it into log to the base 10, we multiply it by 2.303 and this becomes log of 2 to the base 10. The value of log of 2 to the base 10 is obtained from the log table. This value is found to be 0.3010. Thus, we see that the numerator of the product is 0.693 upon lambda. This is our formula for the half-life of a radioactive element. It is given by 0.693 upon lambda.
Let us now see the examples of some half-lives of certain radioactive nuclides. The first one is lithium. Lithium has got a half-life of 0.838 seconds. You can see it disintegrates so fast, that is, after 0.838 seconds, the number will decrease by half. So the rate of decay is fast. This is what we can say. Krypton 89 has a half-life of 3.16 minutes. Sodium has got a half-life of 15 hours. So after every 15 hours, the number will decrease by half. Iodine 131 has a half-life of 8 days. Cobalt 60, 5.27 years, which is quite a big time. Radium 1600 years. You can see it takes 1600 years for radium to decrease the number by half of its original. So it takes very long time for it to disintegrate. Uranium 235, the most commonly used radioactive nuclei, has a half-life of 703 million years. So you can imagine uranium samples that we find now are decaying at the slow rate, and it's taking millions of years to disintegrate. So this is about half-life. It is a very, very important topic in radioactivity. Thank you. See you in the next class with a new topic. Till then, goodbye.